Formula of simple ionic compounds, Part 2. Hello class, before we begin, let's do a quick recap. Okay, we have learned to write shortcuts on the periodic table of the charges of the ions of the elements belonging to the different groups. As we have learned, Group 1 elements will form ions with +1 charge. Group 2 elements will form ions with +2 charge. On the other side, Group 3 elements will form ions with +3 charge. Group 5 elements form ions with -3 charge. Group 6 elements form ions with -2 charge. And Group 7 elements form ions with -1 charge. We've also learned that the Group 0 elements do not form any ions, and the Group 4 elements will share their electrons, as you will learn next time. So please remember the group numbers and what charges their ions formed. Alright, we also learned some common ions, okay, such as lithium being +1, iodide being -1, and so on. Okay, and we also have learned two ways of writing the formula of ionic compounds. Example, in sodium oxide, we can either use the balancing charges method or we can use the cross method. Either way, we will get the formula of Na2O. Alright, so for today, we are going to move on to ions of elements that are not from the main groups. So if you look at the periodic table, okay, we have learned about the ions of the elements in the main groups, group 1 to 8. Now, the question now is, what are the charges for the ions of these elements, the ones in the middle? And that's what we are going to learn today. Alright, for some of them, we just need to memorize. Example, hydrogen is H+, silver is Ag+, and zinc is 2+. But for some of them, okay, we will write them with a bracketed number, and that represents the charges of its ion. Example, copper 2 ion would be Cu2+. Lead 2 ion would be Pb2+. Iron 2 ion would be Fe2+, and iron 3 ion would be Fe3+. So for those with the bracketed numbers, okay, it will correspond to the charges of its ion. Alright, and the rest like hydrogen, silver, and zinc ions, you need to memorize their charges. We also have polyatomic ions. Okay, these are ions that have more than one atoms attached to it. So example, ammonium, okay, NH4. Okay, we have 5 atoms, 1 nitrogen and 4 hydrogens attached together to form an ion of NH4+. And we also have hydroxide, which is O and H attached together with a charge of -1. We have nitrate, NO3, 1 N and 3 oxygen attached together for a charge of -1. We also have carbonate, CO3, with a total charge of 2-, and sulfate, SO4, attached together with a total charge of 2-. Alright, so let's take a closer look on the polyatomic ions. Okay, as mentioned, there are ions that are made of more than one atoms. So let's look at ammonium ion, NH4+. Okay, many times students are confused what is the charge for polyatomic ions. Okay, so for ammonium ion, is the charge 4+ or just +1? Okay, so you need to remember that the 4 belongs to the hydrogen. There are 4 hydrogen atoms. So when the 4 is below, okay, it doesn't refer to the charge. Okay, the 4 belongs to hydrogen in this case. So I can draw it out, and it is like this. 4 hydrogens attached to nitrogen. And this is the charge. Okay, just a plus. The entire molecule has a +1 charge. Alright, another example. carbonate ion. Okay, so what is the charge of the carbonate ion? Is it 3? Is it 2 minus? Alright, so once you see a number below, it represents the number of atoms, okay, of that element. But when the number is on top, that is the charge. So the 3 belongs to oxygen, okay, because it's a number below attached to oxygen. So there are 3 oxygen atoms as I represent here. So 3 oxygen atoms attached to carbon, and the charge is -2. Okay, the entire molecule has -2 charge. Alright, so please do not confuse between the numbers below and the numbers on top. Okay, for the polyatomic ions. Okay, we shall now discuss about ions that sound similar but actually different. Example, hydrogen ion and hydroxide ion. Okay, hydrogen ion is just H+. Hydroxide ion, okay, from the name hydroxide, it is hydrogen and oxygen attached together. Right, it has a charge of -1. We have the nitrite ion, which comes from the nitrogen atom. Then we also have the nitrate ion, which is the polyatomic ion, NO3, charge -1. We have the sulfide ion that comes from the sulfur atom. We also have the sulfate ion, okay, which comes from SO4, 2-. And I shall also talk about carbonate ion, which is CO3, 2-. Okay, so how do we differentiate the nitrite, nitrate, sulfide, sulfate? Okay, so those with the word 8 means they have some oxygen attached. So nitrite is just nitrogen, N3-, and nitrate would be NO3 with charge -1. Same thing, sulfide is just S2-, and sulfate with oxygen attached would be SO4, 2-. We shall now talk about formula writing with these special and complex ions. Okay, let's start with a simple example. Okay, write the chemical formula of sodium nitrate. Okay, I shall use the cross method. So I will have workings and finally derive at the chemical formula. So what is the formula for the sodium ion? Okay, if you look in your periodic table or the table of the common ions, it is Na+. And if you look for the chemical formula of the nitrate ion, it will be NO3-. Okay, so now, okay, are these ions balanced? Okay, they are indeed balanced. Okay, the nitrate ion has a charge of -1. Okay, please take note, the 3 belongs to O. Okay, so the nitrate ion is not have a charge of 3-, but it has a charge of -1. So since they are balanced, Na+ and NO3-, okay, the chemical formula is simply one of each, which is NaNO3. Alright, next. The chemical formula of copper 2 chloride. Okay, the workings and the chemical formula. So if you look, okay, copper has the number 2 bracketed beside it. So the copper ion would be Cu2+. And if you look at the periodic table, the chloride ion comes from chlorine, which is in group 7. So we'll have a charge of Cl-. Alright, are these charges balanced? Okay, they are not. So we need to do cross method. Right, so we cross the number 2 to Cl, but Cl doesn't seem to have a number. Okay, but remember that means it's 1. Alright, so after crossing, we remove all the charges. So we have Cu1, Cl2, but since we don't write the number 1, it is simply CuCl2. Right, and this is the working again without the animations. Okay, one more example. Iron 3 sulfate. So workings and chemical formula. Okay, we have iron 3 Fe3 plus and SO4 2 minus. Alright, so since the charges don't balance, okay, we need to do the cross method. So we bring the 3 over to SO4 and we bring the 2 over to Fe. And we will remove the charges. Alright, so we will get Fe2SO43. Does this make sense? SO43. Alright, so this is wrong. Alright, so we need 3 of SO4. So how do we solve this? Alright, since we need 3 of SO4, we need to put brackets so that we denote we need 3 of SO4, not 43 of oxygen. So the final answer would be Fe2SO4 brackets 3. So here's the working again without the animations. So please remember, polyatomic ions need brackets when there are more than one of them. Okay, one more example. Writing the chemical formula of zinc hydroxide. Okay, we have the workings and chemical formula. Zinc would be 2 plus, is a special ion, and hydroxide will be OH minus. So we need to do the cross method to bring over to OH, and since OH charge is -1, we can write the 1 there and bring over. Alright, so we remove the charges and we get ZnOH2. Alright, this might look correct, but it is actually wrong. Okay, because we need 2 of OH. Okay, we need 2 of OH, not just 2 of H. So we need to bracket the OH together. So it is Zn bracket OH2. Alright. So this is once again the working without the animations. So OH is a polyatomic ion. And please remember, polyatomic ions need brackets when there are more than one of them. Okay. I shall do the same example, but this time with the balancing method. We have zinc hydroxide. So zinc is 2 plus. Okay, and OH is -1. So the total charge for the positive side is +2, and the total charge for the negative side is -1. Okay, so to balance it, we need another OH minus for a total charge of -2. So we need 1 Zn and 2 of OH. So the formula would be Zn bracket OH2. Alright, so reminder again, polyatomic ions need brackets when there are more than one of them. Because if we don't write the brackets, we write ZnOH2. Okay, this means 2 hydrogen, but we want 2 of OH. So this is a wrong formula. Alright, with that, try the practice questions on your own. I'll see you next time. Take care.